Hi, this is Mrs. Doris. This is Lesson 6-2, Solving Systems Using Substitution. The objective is that you will solve systems of equations using substitution. And again, we're studying systems because we can use them to solve real-life problems. This substitution method is the second of three methods of solving systems that you will learn. The first we learned was graphing, and the second one is substitution, and then we have one more method in Lesson 6-3. All right, so the substitution method involves solving one of the equations for one of the variables. Then we substitute the expression for the variable into the other equation. All right, so problem 1. Using substitution, what is the solution of the system? Use substitution and check your answer. All right, well, in this case, they've done all the work for us. We have y equals 2x plus 7, and we have y equals x plus 1. So, in other words, both equations have already been solved for y. So what we're going to do is we're going to take this expression for y, x minus 1, and we're going to substitute it into the first equation for y. So here's what we get. Substituting x minus 1 for the y in this top equation right here, I have on the right side 2x plus 7. And now we simply solve for x. So let's see, I want to get my x's together. I'm going to subtract x from both sides. X minus x is 0. And 0 minus 1 is negative 1. On the right-hand side, 2x minus 1x is 1x plus 7. Then subtracting 7 from each side, negative 1 minus 7 is negative 8, and that's equal to x. All right, so in my answer, I have x is negative 8. All right, let's now solve for y. And to solve for y, you can use either equation. In fact, we'll check it out in both just to make sure that we have the correct solution. So in the second equation, I'm going to take my negative 8 and put it in for the x. So I have y equals negative 8 minus 1. So y would be equal to negative 9. So it appears that my y would be negative 9. Now, we've basically used the y equals x minus 1 to find the answer. Let's check it by using the other one. All right, so I'm going to take the top equation and come down here and put negative 9 in for my y. I've got 2 times x, and x was negative 8, plus 7, and see if I get a true statement. All right, 2 times negative 8 is negative 16. Negative 16 plus 7 is negative 9, and so it checks out. And so my solution would be negative 8, negative 9. All right, problem 2, solving for a variable and using substitution. What is the solution of the system? Use substitution and check your answer. All right, so here it's not quite so nice and neat. I am going to have to solve for one of the variables. Now, as I look at the first equation, I see that y has a coefficient of 6, x has a coefficient of 5, and so neither variable is going to be easy to isolate. It's not hard to isolate a variable. The problem is I'm going to have a fraction as a result. So let's look at equation number 2. Here, my x has a coefficient of 1. My y has a coefficient of 3. Well, what you want to look for if you're going to use substitution is you want to find a variable that has a coefficient of 1. 1 is the easiest way to do it in order to use substitution. So what we're going to do is we're going to take this second equation and solve for the x. To solve for the x, what I have to get rid of is my 3y. So I'm going to subtract 3y from both sides. All right, on the left side, my plus 3y and minus 3y cancel each other out. So I have x equals, and it doesn't matter which order, I'm going to put my variable term first, negative 3y and then minus 7. All right, now we are ready to use substitution. What I'm going to do, since x is equal to this expression, I'm going to then take it and put it into the first equation for the x. So let me rewrite equation number 1, substituting. I have 6y plus 5. Now, this x right here is what I'm going to substitute with the negative 3y minus 7, and completing my equation, it's equal to 8. All right, if you study this, pause it and study this for a moment to make sure that you understand what just happened. We took this equation, the first equation, and we substituted the expression that we received when we solved for x in the second equation. All right, now we're ready here to find y. So, first thing we have to do is distribute. 5 times negative 3y would be negative 15y, and 5 times minus 7 would be minus 35. All right, let's combine our like terms. 6y plus negative 15y would be negative 9y. All right, next let's add 35 to both sides. All right, and negative 9y is going to be equal to 43. And you can see here, it's a good thing that we didn't graph this, because we are going to get an answer that's not going to be very pretty. All right, dividing both sides by negative 9, we get y equals we'll just leave it 43 over negative 9. Okay, so I've run out of room, so I'm just going to circle it right there. 43 over negative 9. Now, the next thing that we have to do is we have to substitute it into one of our equations and solve for the x. So what I'm going to do is I'm going to use my revised equation right here to find my x, and then we're going to substitute it into both of the original equations to make sure that it's true. All right, so substituting in 43 over negative 9, all right, and then subtracting 7. Let's see what we get. We have negative 3 goes into negative 9 3 times. So it's basically 43 divided by 3. 43 divided by 3 is 14 and 1/3 minus 7, which would give us 7 and 1/3. Okay? So it appears that my solution, I'm going to write it right up here, is my x is 7 and 1/3, My y, I'm going to go ahead, I'll go ahead and switch this now into a mixed number form. 9 goes into 43 4 times, so it'd be a negative 4, and 7/9. All right, so there, that appears to be my solution. To check it now, we're going to put 7 1/3 in for x, and negative 4 7/9 in for y to check it. So pause right now, take your calculator, and see if it agrees with both equations. All right, using this substitution method and many of your problems that you will do, you will get nice integer coordinates. In this one we did not, and starting off with one of the worst problems that you can have is not a bad idea, because it does show you why graphing would be horrible for this problem. Because you do not have a point of intersection that has an integer for the coordinates. All right, let's go on. If you have a question, again, please jot it down and we'll answer it in class. Okay, problem 3, using systems of equations. You pay $22 to rent 6 video games. The store charges $4 for new games and $2 for older games. How many, that should be new games, did you rent? Okay, so basically we have two unknowns. We have new games and we have older games. So let's use, how about, let's define our variables. N will represent the number of new games, and O is a terrible variable to use because it looks like a 0. Let's use just G for the number of older games. All right, so let's write our system of equations. First of all, we are told that we rented 6 video games. Some are new, some are old. So our first equation is going to be N, the number of new games, plus G, the number of older games, and that's going to be equal to 6, since that's how many we rented. The second equation is going to have to do with the cost. All right, we have $4 for new games, so that would be 4 times N. $4 times the number of new games we rented. Plus, it's $2 for older games, so 2 times G, and we paid $22. So there's our second equation. All right, we're going to solve this using substitution. So I can see that in my first equation here, I have N has a coefficient of 1, and G has a coefficient of 1. So it really doesn't matter which one I solve for N. I'm going to, so I can solve for N or G, is what I meant to say. So I'm going to go ahead and just subtract the G from both sides. And since my space is limited, if you have a question about what I'm doing here, please ask. N would be equal to 6 minus G. Okay? Now we're going to take this expression, 6 minus G, and substitute it into the second equation for the N. So I have 4 times 6 minus G, and then finishing the rest of the equation, plus 2G equals 22. All right, let's see what we get. All right, distributing 4 times 6 is 24, minus 4 times G is 4G, plus 2G is equal to 22. All right, Combining my like terms, minus 4g plus 2g would be a minus 2g equals 22. Let's subtract 24 from each side. 0 minus 2g is negative 2g, and 22 minus 24 is negative 2. Divide both sides by negative 2, and g is equal to 1. So it appears that one older game was rented. All right, we can easily use then our little equation right up here to solve for the number of new games. The number of new games is equal to 6 minus the one older game. So it appears that new games we rented were 5. So if we were writing this, I would not use an ordered pair in this case. I would simply say we had 5 new games and 1 older game. If you wrote this as an ordered pair, then I would put the coordinates in alphabetical order. So G would come first and then N. All right, so let's check it out and make sure that we're okay. First of all, in our first equation, let's go back to the original ones. N plus G equals 6. 5 plus 1 equals 6. We can do that mentally, and so we know we're correct. Let's check out the other one over here. So 4 times 1 new game plus 2 times, I'm sorry, new games was 5. Let me change that. New games was 5. Plus 1 older game. 2 times 1 older game is $22. And let's see if it checks out. 4 times 5 is 20. 2 times 1 is 2. And yes, 20 plus 2 is equal to 22. So it does check out. And of course, using our first equation, as I said, 5 plus 1 is equal to 6. And that checks out as well. So to answer the question, how many new games did you rent? Our answer would be 5 new games. All right, problem 4. Systems with infinitely many solutions or no solution. All right, so the question is, how many solutions does the system have? All right, well, the first thing that we probably want to do is to write them so that our variables are in the same order. And since x comes before y, I'm going to leave this equation the way it is, and I'm going to rewrite the top equation so that my x term comes first. So that would be 5x plus 6y is equal to 8. All right, now what I would suggest you do is compare the two equations. Compare the coefficients, 2.5 with 5. How do you get from 2.5 to 5? Or how do you get from 3 to 6? Or from 4 to 8? And what you notice is if I took this equation right here and multiplied it by 2, I would get this equation right here. 2.5 times 2 is 5x. 3y times 2 is 6y. And 4 times 2 is 8. So the two equations are exactly the same, and so therefore it's the same line, and we would have infinitely many solutions. All right, I have a few more problems. If you would want to, and these are on your notes as well, so we're going to work through them as quickly as we can. X here is already isolated, so I'm going to take this expression for X and substitute it in right here. So I have 3 times, substituting 4y for the X, minus y equals 70. Well, 3 times 4y is 12y, minus y equals 70. 12y minus 1y is 11y. Okay, dividing by 11, I get y equals, and 70 over 11, or let's see, it goes in 6 times with 4 left over, 6 and 4/11. Now, we have to find the x. So let's use our top equation right here, and x is equal to 4 times y. So I'm going to take 4 times my y, and I'm going to go back to my improper fraction form. 4 times 70 is 280 divided by 11. All right, and let's see, we're going to try to do this without a calculator here. 11 goes into 28 2 times. That would be 22. Taken away from 28 leaves 6 and bring down the 0. And 11 would go in 5 times, which is 55. And 55 from 60 leaves 5, so 25 and 5/11. So our solution is 25 and 5/11 and for x, and our y 6 and 4/11. All right, let's go to number 2. Hopefully we'll get a prettier answer this time. All right, again, y has already been isolated, and so we're going to take this expression and substitute it into this equation for the y. So I have negative 2x plus 5. Now here's where I substitute for the y the 3x minus 4, and that should be equal to 19. Distributing, I get 5 times 3x is 15x, minus 5 times 4 is 20. All right, combining my like terms, negative 2x plus 15x is 13x, minus 20 equals 19. Add 20 to both sides. All right, and I get 13x is equal to 39. Oh, good. We're going to get a nice, pretty answer this time. Divide both sides by 13, and x is 3. Yay. All right, so I'm going to start my ordered pair up here. I have x is 3. Now, let's use our second equation and substitute 3 in for the x and see what we get. So we have 3 times 3 minus 4. I'm going to do this in my head because I don't have a lot of room. 3 times 3 is 9. Minus the 4 is 5. So it appears my solution is the ordered pair 3, 5. Let's check that in the top equation since we used the bottom equation to find it. So let's see if we can do this in our heads. 2 times negative 2 times 3 is negative 6, plus 5 times 5 is 25. Is that equal to 19? And the answer is yes, it is. So we have a solution in 3, 5. All right, in the next ones, tell whether the system has one solution, infinitely many solutions, or no solution. All right, so let's see what we get. I'm going to substitute 2x plus 1 for the y right here. So I have 4x minus 2. Y is equal to 2x plus 1 in the top equation, so I'm substituting that in, equals 6. All right, let's distribute. Minus 2 times 2x is minus 4x. Minus 2 times 1 would be minus 2. All right, well, here we go. 4x minus 4x is 0. And so this cancels out, and 0 minus 2 is simply negative 2 equals 6. This is not true, so this is where we have a no solution. Okay, let's look at the next one. Okay, here I have not solved for a particular variable, so let's do that. Actually, I could solve for x very easily, but I think what I want to do, I'm going to make y have a coefficient of 1 right here. And I can do that if I multiply the whole equation by 2. All right, and since I'm doing the same thing to both sides, let me show it this way. Since I'm multiplying both sides by 2, I have an equivalent equation. So 2 times x is 2x, 2 times 15 is 30, and on the right side, 1/2 y times 2 is simply y. So now I'm going to take this expression and substitute it in for this y right here. So I have negative x plus 1/2 times 2x plus 30 is equal to 13. All right, 1/2 times 2x is simply 1x. 1/2 times 30 is 15. And that's equal to 13. Okay. Let's go ahead and solve. Negative x plus x is 0. 0 plus 15 is 15. And on the right-hand side, I have 13. Again, we have a false statement, so this is no solution. If I were to get a true statement, then I would have an infinite number of solutions. All right, we have one more problem. Number 5. In a talent show of singing and comedy acts, singing acts are 5 minutes long, another typo, and comedy acts are 3 minutes long. The show has 12 acts and lasts 50 minutes. How many singing acts and how many comedy acts are in the show? All right, well, here's our variables right here, and to save a little space, I'm going to define them within the problem. Let's use S to be the number of singing acts, and how about C for the number of comedy acts? All right, so we are told that the show has 12 acts right here. So one of our equations is going to be the number of singing acts plus the number of comedy acts is equal to 12. All right, our second equation has to do with the length. So we are told that singing acts are 5 minutes long, so that would be 5 minutes times each singing act. Comedy acts are 3 minutes long, so 3 minutes times the number of comedy acts, and the whole show lasts 50 minutes. So here are our two equations. I'm going to solve the first equation, and it doesn't matter which variable you choose. I'll solve for s, which means that I have to subtract the c from both sides. So I end up with 12 minus c. Now I'm going to take that expression for s and substitute it in for the s in the second equation. So I have 5 times 12 minus c plus 3c equals 50. 5 times 12 is 60. 5 times C is 5C, plus 3C equals 50. Combining like terms, negative 5C plus 3C is negative 2C. So I have 60 minus 2C is equal to 50. Subtract 60 from each side, and I end up with negative 2C is equal to negative 10. And dividing both sides by negative 2, I end up with C equals 5. So there must be 5 comedy acts. And I'm going to write that up here at the top. 5 comedy acts. All right, now we can go back to our equations and solve for the number of singing acts. Using the first equation, let me get a different color here, and putting in 5 for the comedy singing acts plus 5 comedy acts is a total of 12. And this is one you can solve mentally without showing this, but that would be 7 singing acts. Now let's use the second equation to check it. All right, and I'll switch colors again. Here we go. All right, so 5 singing acts, or 5 minutes for each singing act would be 5 times the 7, plus 3 minutes for each comedy act, and there are 5, and we should get a total of 50 minutes. 5 times 7 is 35. 3 times 5 is 15. And yes, 35 plus 15 is equal to 50, and so we have a correct answer. All right, that's it. If you have questions, please jot them down or email me, and we'll answer those in class. Thank you.